morning and welcome to this live stream. It's Sunday the 25th of April and this morning, of course, I'll take your questions live as ever if you've got questions for me or you just want to chat. But the focus topic for today is the maths of the pandemic for primary school children. And today I'm really focusing on children aged, sorry that's shaking slightly, aged 9 to 11, and especially those who are about to make the transition to secondary school. So a lot of schools will have thought about children's pandemic experience, about their emotional well-being, about their need to make sense of what's going on. Now for your children who are 10 or 11 years old, they're capable of quite a sophisticated understanding, and the distance that we've got now from the worst of it here in the UK, obviously things are horrific in India just now, will help them to understand it and engage with it, and this is their life and their primary school journey. So there are lots of benefits on getting them to do a piece of work now, a cross-curricular piece of work which reflects on the pandemic and their experience of it and gives voice to them and their lives as they are now. And today I want to talk about some of the maths that you could do with that, just to give you some insight into quite how amazing and powerful that maths can be. So if we just start to look at some of the numbers of the pandemic, I'm working on UK numbers, of course you can easily adapt these for your country. Population of the UK is 66.65 million, diagnosed cases 4.4 million, deaths 127k. And the first question is, what are those numbers? And that's a really big question. It's an important question on this stage. Children should have done quite a bit of work on large numbers, and I have a video on that. I'll put a link to it in the description of this video. You may not be able to see the description on a phone, but you should be able to see it on a laptop. If you just click below it, I'll just make a note of that, large numbers. But there's a step on here in interpreting 66.65 million. Best way to understand it is that millions have 6 zeros. So that 66 million is 66 with 6 zeros, only the first two digits are going to be the 6 and the 5. And we can remind ourselves how we group these numbers in 3. That's explained in the video on large numbers because we have 3 dimensions, and it's a great way to understand the geometry of number with your Dean's blocks. So is that 6.65 million? Just take a moment to explore that and convince yourselves and each other that it is. That's that number there. So 4.4 million, what's that going to be? Let your children think about that. Can they puzzle it out? Well, 4 million would be 4 with 6 zeros, but 4.4 million. And you might have an exact number for deaths, 127,000. And it's quite a level. You can bring the whole class together, including the children who are struggling, because this is just that little bit beyond what everyone's been doing. So they're going to need support and explanation. They're all going to need support and explanation. So it's a leveler in that the bright sparks aren't getting it instantly. They need to think and are challenged. So there's some key numbers of our pandemic. How can we interpret those numbers? How can we make sense of them in our minds? And that's a big question, and you can put that to the children. Let them talk. Let them think. One thing I would like you to think about is, what is 1% of the population? Well, we move all digits 2 places to the right, divide by 100 to find 100th, which is 1%, which means effectively we'd be crossing off 2 zeros, and then we can start to try and compare these numbers. And it turns out that this is a bit less than 1/4%. So that's about 1 in 4 or 500 people has died. And you can do similar explorations of these numbers, just let children play with them. Because this is a little bit beyond the curriculum, it doesn't matter if they make mistakes, as long as they're having sensible discussions about the sizes of numbers. These K numbers, thousands, they're particularly crucial to children because they see numbers of Ks of likes on social media, on YouTube and on TikTok or whatever else they're following. And it's important that they can actually unpack it and understand what it means. Hello, I can see there are some people watching. If you've got any questions or if you just want to say hi, that'd be lovely. And you could also do some work on vaccination. What proportion of the population is 33,500,000? What proportion? And that leads to the insight that proportion can be percentage or fraction. Links all that together. And that is now just above half, so just above 50%. What proportion are fully vaccinated? Very challenging stuff, very relevant. So as a Year 6 primary or mixed Year 5-6 primary, I'll be looking to do a lot on the narrative of the pandemic. You can do geography, it's totally cross-curricular, it absolutely encompasses everything. But I would take some time to talk about these numbers, and if it felt right, I might even do that with small groups of children at a time. Maybe starting it off from the board, maybe they're already working on other aspects of this project, but then come and have these discussions with small groups at their tables to really draw out their understanding and play around with their sense of number. So we are rehearsing and consolidating lots of topics that we've done this year in maths. There's a line graph. Line graphs are key. Can they read it and make sense of it? This is just about the number of cases per day during the pandemic. Great chance to reflect over the last year. What happened at what time? This first peak of diagnosed cases was incredibly low because we weren't testing. So it should really have been way up here. We can never know. But that's underreported cases, which brings us back to the number of diagnosed cases, of course, being an underestimate. So on this we have in detail the spikes, a little bar for each day, and then the line is the 7-day rolling average. Well, the average is the mean, and they've done the mean, and there's a video on the mean, which I'll put a link to as well. I'll just make a note on that. So 7-day rolling average is, I think in this case, it's the 7 days up to the date, the average of those values, but it might be the 3 days either side, including the date, to create the value that's on the line that's being connected up. So that's really nice to talk about, to consolidate and review their work on the mean average. And it allows us to create this line graph which makes more sense of the data because the data is distorted by weekly cycles of reporting. So less cases get reported at the weekend and it smooths that out. And if you ask the children to come up with numbers that have been important for the pandemic, one of the numbers they might come up with is the R rate. So you could do a little bit of playing with that. Now the R rate represents the change in case numbers, and I think it's every 3 days. I've been looking for a precise definition of this and it doesn't seem to exist, but I think contagion factor is 3 days. So if we pick a date and start at 2,500 cases per day, I've just done this in Excel, so I formatted this column as dates and just put that in as 2/3, the 2nd of March. And then I put in a number here, and this is my cases per day. And then in this next cell, I typed equals, and I clicked on the first cell +3. And it gave me a date 3 days later. And I did that a couple more times, and then I was able just to fill down, and it continued the pattern. If anyone's watching this and they'd like a screen capture video on how to do this, then just let me know in the comments, or if you have any particular questions, you're getting stuck with this kind of thing, just let me know. And well, what does 1.2 mean? It means an increase of 20%. 1.03 would be an increase of 3%. 1.17 would be a 17% increase, and so on. So children could actually work this out by hand if they've done some work on percentage. 1% would be 25, so 20% would be 20 lots of 25, which is 500. Therefore, by 3 days later, we've got 3,000 cases per day because it's gone up by 500. So an R of 1.2 is a 20% increase, so they could do that by hand, but I just put in the formula equals and then the previous cell. So that one, just clicked on it to get the cell reference in it, and then star for times, and then 1.2. And it gave me that result, and then I could just fill down. And that makes it really easy to change the R rate, because you just need to change that one cell and everything else flows through. And then I selected those two columns with the titles, and it gave me this graph, and you start to see what exponential growth is, how little 2,500 cases a day is and how quickly it's increased. Sorry, that's just a mark where my pen's gone through 2 sheets of paper. And this is all linked in real time in Excel. It's great to give children some experience with Excel. Really powerful line graph, and it links us back to the shape of the graph here, so we can start to get a feel for the exponential growth and how it's curtailed by lockdowns. So here at 2,500 starting point and an R of 1.2, which is quite low, that's like masks but not much lockdown. We're up to 1 million cases a day in 3 months. Now that never happened. We only got up to about 60,000 cases a day, much, much less because of the lockdowns. We can start to explain all that. So the focus in all of this needs to be on children's emotional health and confidence, and you may need to take some substantial side steps with a project if a child's been bereaved. Let's just engage with that. What's that meant for them? Prioritise them having the space that they need to understand their world. Where there's been stress in families because of the pandemic, it's very likely that children will not have been prioritised in having the space to unpack their own thoughts and their own reflections on it. So it's incredibly important to do that, but it's also tremendously powerful just to do a little bit of work on the maths. Now this was quite challenging maths. It's mainly secondary school maths, but it's also stuff that children should be able to have an appreciation of. And the context here, the pandemic, gives, when you give a powerful context, children can access and appreciate higher level maths without feeling stressed because they don't have to deliver it in exercises yet. But this is going to help them understand some of the topics that will come up them at secondary school with a lot more confidence than if they'd never seen this harder maths. If it's challenging for you as a teacher, please just put your comments either here on YouTube or back in the Facebook groups. It's Expert Primary Maths Teaching is a Facebook group that I always check. But usually if I've posted a link to this video, then if you comment on it, there's a good chance I'll pick that up and reply to your comments. And I can do little screen capture videos of using Excel to analyse this data. And I'm really happy to do work on particular points that I've said today that maybe you don't quite understand. It's perfectly reasonable, you're a primary school teacher. Okay, I'll let you get back to your Sundays. I'll get back to looking after my husband with long COVID. Hope you're all well. Take care. Good luck with your week. Bye for now.